So here we've got the June 2018 Algebra 1 Regents short answer. Number 25 is a graph of the square root function x plus 2 inside the square root. So I'm going to go to my calculator. I'm going to do square root of x plus 2 is inside. So this is going to be a transformation of the x squared function going left 2. So x plus 2 inside. So as you'll see there, it normally starts here and goes like that. But instead, because of the left 2 transformation, it's going to start at negative 2, 0, which if you could do Control T, you will see that. At negative 2 is 0. There's nothing else after that. I'm going to do only the easy points here. I'm going to do negative 1 is 1. I'm going to skip all the decimals. You don't need those. 2 is 2. And 7, the endpoint it wants. 3, 4, 5, 6, 7 is 3. So if we just connect those 3, you don't want an arrow here. It only wants that part of the graph. So we just do between negative 2 and 7, connect it, all that good stuff, and you move on. So is this a nonlinear function? So if it's nonlinear, we want to see, well, is it linear? The x changes here every time by 1. So that's a pretty easy thing to check with the y's. This is a plus 2, a plus 4, and a plus 8. In order to be linear, it has to be a constant rate of change. This is not a constant rate of change, so it's not linear. So Caleb is correct. It is not linear. Correct. This is not linear because there is no constant rate of change. You're not a constant rate. You might think it is because it's multiplying by 2, but that would be exponential. So this is not a linear function. This is an exponential function. Okay, for this one, solving a quadratic to the nearest tenth, this is a hint. Nearest tenth there means it's not factorable, so don't even try and factor it. So you can use quadratic formula, you can use completing the square, whatever you want to do, or besides factoring. I'm going to do quadratic formula, x equals negative b, so a equals 1, b equals 1, c equals negative 5. The numbers in front, so a, b, and c. So don't forget the plus or minus. Negative b plus or minus the square root of b squared. Sorry, it's a positive one. Minus 4ac all over 2a. You don't have to show much work for this because this is a 2-point question. So what you could do is you could go over here and just do, if you do Control divide, I can get negative 1 plus the square root of 1 squared. Probably should put it in parentheses just in case if it's negative, the parentheses do matter. If it's positive, it doesn't. But I'm going to show it just because, I don't know, it's good to have it to put the thing you're squaring in parentheses. Then minus 4 times 1 times negative 5, all divided by 2 times 1. There's our first answer. So 1.79, what's nearest tenth? So 1.8, or what I'm going to do is I'm going to copy and paste. If I hit enter here, it's going to copy and paste. I'm going to go over and change that to a minus. And then we get the other answer. So negative 2.8. Done. That's all you really need to do. You don't have to show a whole bunch of steps because it's a 2-point question and it wants nearest tenth. So done. To check your work, you could do the menu. If you go to Algebra and do polynomial tools here, choice 3. You can do find roots of a polynomial. It's already set equal to 0, so it's easy to do for that. Degree 2, A1 is really just A. A2 is really just A, so that's just 1. And then, A1 is our B, so that's 1. And then A0 is our C, negative 5. And if I hit this, I should get the same answers, and we do. So that's helpful to check our work. And we go on to the next. So this is P of X. So it wants us to graph P of X plus 2. So this is a transformation. Do we have to explain anything? Nope, we do not. It says sketch, but we're not really sketching, right? We're drawing it as accurately as possible. This is a transformation left 2. If you're ever not sure, you could just make up something like, say, P of X equals X squared, and then just say, okay, what would X plus 2 squared be? Because that would be P of X plus 2, be putting X plus 2 in for X. And you can see it on your graph which direction it has to go. But a plus 2 is a left 2. I'm going to find some key points like this vertex here, this point here, this point here. The more points you use, the more accurate you are. So I'm going to find a whole bunch. Of the original, I'm going to move each of those points left 2 to make my new function. So every one of those dots, I'm just moving 2 to the left. And then that is the new one. This is p of x plus 2. All right, 29 here. So number of seconds it takes to hit the ground. So we're looking to see when the height is 0. So it's really wanting us to solve this equation. 0 equals negative 16t squared plus 256. All right, I'm going to add the 16t squared over to make it positive. So 16t squared. Notice how it says to solve algebraically. That means you have to solve using algebra, using like steps, solving an equation. You can't just graph it and see where the 0 is. Divided by 16, so 256 over 16 is 16. T squared is 16. Now, normally here when you take square root of both sides in order to get t by itself, you got to do plus or minus. So technically it should be plus or minus 4. But if we're talking about an apple falling from the sky or from a tree or whatever, a tower, I guess, we're not going to have negative seconds. So negative 4 we're going to omit, and t is going to equal only 4 seconds. It's important to make sense of your answer and box in the final answer. We don't want to show the negative 4 as our final answer because it's not negative 4 seconds. This one, there's a lot of different ways to approach this question. What I'm going to do is, well, I know it says exact value. So I could show on here menu, if you go to number, or I lied, not number, algebra, numerical solve, or just type n solve. You could type this whole thing in. Now I'm going to show you this, and you're going to be like, this is a waste of time once you see the answer, but that's okay. Because the question is asking for exact value. An exact value essentially is meaning do not get a random decimal like we just got, okay? And of course, it's algebraically, it wants you to show steps. I have no steps to show, so that's a problem too. But we want to get to an answer. It's going to be a fraction, it's going to be a decimal. Let's figure out how to do that. 2/3. There's many different ways to get rid of 2/3. I'm going to get rid of just the thirds part of it because that's the only problematic part. So I'm going to show that by multiplying both sides by 3. Now, here's where it gets kind of tricky. There's 2 things technically inside the left parenthesis because this whole thing is connected with multiplication. So when you distribute the 3 to the 6 and get 18, that's all great. But 3 times this whole thing is just a one-time thing. It's not like to the x to the 5 to the 2/3. It's that whole thing together. So it's going to be minus 3 times 2/3 x plus 5. Kind of like that equals 12x. So everything gets multiplied by 3, but it may look different than what you may expect. You don't multiply the 3 into everything because you just do 3 times 2/3, which is then just 2. So 18 minus 2 times x plus 5 is 12x. That's the way I recommend doing this one, just to get rid of that fraction. Then it's a lot easier. Just multiply the negative 2 in, bring down everything else, solve for x by getting all the x's to the same side. This is 8 equals 14x, divided by 14. And it says exact value. It doesn't say simplest form. So 8/14 should be full credit. There's no real reason you have to simplify. If you wanted to, you could go to your calculator. It does the simplifying for you. 8/14 is 4/7. If you got a nice Inspire, it can do that simplifying for you. So either way is fine. It doesn't say, again, to simplify, but that's not hard to do either. It wouldn't hurt to do Control-Enter here and make sure that decimal matches the end solve, and it does, so we're good to go. 31, is this rational or irrational? So square root of 16 is 4. 4 is rational. 4/7 is rational because it's a fraction. If you can write it as a fraction, it's rational. So a rational times a rational is irrational. So yes, it is rational. It is rational. Now, I would add more to it than this. Rational. Why is this? So square root of 16, like I said, is 4 times 4 sevenths. You can show this. This would be 16 sevenths. Again, written as a fraction. You can write it as a fraction, write as a fraction of two integers. That means it's rational. Or you could also say, well, 16 sevenths, if you do control divide, that equals 2.285714285714, which means this part's repeating. So rational numbers either have a repeating decimal, or they have a terminating decimal, like 1/2. That also makes them rational. It's irrational if the decimal is unpredictable. For example, the square root of 7. Unpredictable decimal, not repeating, not stopping, that's irrational. Pi is another great example of an irrational number. A lot of different ways to say that, but hopefully that would be enough. All right, let's graph this function. So you can use your calculator for this. The problem is it's not going to show you a point, an open circle. So that's going to be a little bit tricky. So I'm going to actually not use the calculator. So I'm going to do x. I'm going to do this part first. X when x is greater than or equal to 2. So at 2, y is 2 because it's equal to x. And the slope is 1 since it's just x. Greater than or equal to means it, goes to the right. And it'll go forever. So I'm going to use my ruler. And that's that part of it. That's the bottom part. The other part is negative 1/2 x for less than 2. So I'm going to start at a y-intercept of 0 and go down 1, right 2. But then it says less than 2. So actually that should be an open circle because that's an x of 2. And then I'm going to follow that slope of 1/2 going the opposite way here. Again, using the ruler and connecting those to make the nice line. That wasn't the best line. Let's try again. That's pretty good. Not bad. I was trying to fix it. Oh, well. Good enough. There it is. Again, you could graph this on your calculator. You'll see the table. The problem is it's not going to show you this open circle. So if you rely on the calculator, you're not going to get that, and you're going to lose a whole point for that graph. So I recommend doing it not with the calculator. Doing it yourself, making a table for each part also works. If you just do a little table here. So x, so it's just 2 is 2, 3 is 3, etc. for that part. And the other part, negative 1/2 x for less than 2. So if I do negative 4, negative 3, negative 2, negative 1, 0, 1, 2. At 2, negative 1/2 of x would be negative 1. At 0, it's 0. So this is negative 1/2. This would be 1/2. This would be 1. Just following the pattern backwards. This would be 3/2 and 2. You can always do that to make your graph. Part 3s. So looking at this exponential function, the y-intercept. So exponential functions always look like y equals a times b to the x, where a is the y-intercept, or the initial value, and b is the growth rate, or the decay rate, the growth factor, if you will. So what do these numbers mean? Well, 20 represents the initial amount. So 20 is the initial amount, the y-intercept, of what we're talking about, which is rabbits. Whereas 1.014, okay, we started 100% always. So 100% became 1.014. So 100% became 101.4% because those two things are equal. So that means it's increasing. So 1.014 is obviously the growth rate. The growth factor, I'm going to call it growth factor, which means it's increasing by 1.4% each day. because day is the domain. So average rate of change from day 50 to day 100. So this is where you want to make a little table. X and P of X, 50 to 100. So I'm going to go here. I'm going to make a graph. So it was 20 times 1.014 to the X. Control T. I'm going to go do my table here. I'm going to make it show 50 first and then count by 50. That way it shows the ones I want, 50 and 100. So 50 is 40.08 and a bunch of zeros. So I'm going to skip all the extra zeros. I don't need those. And then 100 is 80.32033. That should be enough in order to get nearest 10th accuracy. So rate of change, so y change over x change. So if I go back to my calculator and do 80.32033 minus 40.08, that gives us about 40.24033. This change is obviously 50. So 40.24033 divided by 50. So divide that answer by 50. Oops, by 50. And we get 0.8048066. Nearest tenth, though, is 0.8. Make your answer very obvious. Box it in. Okay. For this one here, I don't love the wording of this question. I feel like it's a little bit unfair, the way it's worded. Just because I feel like it's a little bit mean. So it says it charges $7 to park for the first 2 hours, and then each additional hour for this garage A costs $3 per hour. Garage B is a flat $3.25 per hour. So when they park for at least 2 hours, write equations to model the cost in the parking lot for a total of X hours. So when a person, okay. So what I would do for A, it says to use, it just says X. So does it say, it doesn't say what to use for that. I'm just going to use A. A equals 7 for the 2 hours, and then each additional hour. So you think it would just be 3 times X. That would be nice, but it's not, because if you put in 1 there, say X equals 1, because X is the total number of hours. You put 1 in there, it's not actually going to work, because that would be 7 plus 3 times 1, which is 10. It's supposed to be $7 for the first 2 hours, and that doesn't work. So in order to account for that 2-hour difference that we need, you have to change that X to be X minus 2. That way, whatever you put in here, say you do 3 hours, you're only actually paying for 1 extra hour after the first 2. It's the extra part that can be confusing, which I know I don't like very much. Whereas the B is just $3.25 per hour. So that should be fine. I don't see any reason why that wouldn't work. If you wanted to, you could say, well, it's $6.50 because you have to park for at least 2 hours, plus $3.25 for each extra hour after 2 hours. But if you multiply this in, it's equivalent. 325x minus 650 plus 650, those cancel. So I would just call it 3.25x. Now, determine when they're equal. 7 plus 3 times x minus 2. When does that equal 3.25x? That's just a simple equation once you multiply the 3 in, 3x minus 6. The key is if you mess up the first part, keep going. Okay, with these multiple part questions, don't give up on it. Either make something up or just try something. That way you get parts for later on in the test here. So divide by here, and we'll get our answer, which is 4. So after 4 hours total, so 4 hours, the total number of hours, or they're going to be the same. 35. These questions are very common. They love these kind of questions. Let's solve each one for y. So 2y plus 3x is less than or equal to 14. Minus 3x minus 3x, 2y, sorry, is less than or equal to 14 minus 3x. Divide by 2, everything. y is less than or equal to 7 minus 3/2 x. The other one, I'm going to move the y over to avoid the, dividing by negative. 4x is less than 2 plus y, minus 2 minus 2. 4x is less than 2. Or sorry, 4x minus 2 is less than y. Flip the whole thing around. That's the same thing as y is greater than 4x minus 2. If you just flip the y to the other side, flip the symbol, there's our two equations, or our two inequalities. So 7 minus 3/2 x, I'm going to do that one first. So 1, 2, 3, 4, 5, 6, 7. There's the y-intercept. Negative 3 over 2, so slope down 3, right 2, down 3, right 2, to build that slope of negative 3/2. It can be a solid line here because it's less than or equal to. So we're going to do solid line like this. Arrows on the ends of that line because it goes forever. And y is less than or equal to that line, so we're going to shade below it. So this section here would be y is less than or equal to 7 minus 3/2 x. That's our first solution. The other one is y is greater than 4x minus 2. So minus 2 for the y-intercept, and then 4 for the slope. So up 4 over 1. I'm going to follow the pattern backwards. I always like to fill up the grid as much as possible with these dots to have as much accuracy as we can. The more dots, the more accurate it is. Then use your line tool, your ruler, line making tool, aka ruler, to make that line. This one's going to be a dashed line though. It's greater than, so it's not going to be equal to, which means it's going to be dashed. So I'm going to go back and make this dashed. That's a very small eraser. There we go. We're getting there. So it's this line right here. And this is y is greater than 4x minus 2. So we're going to shade above it. Now, these can be kind of tricky to shade above it. Because you're like, well, what is above? It almost seems more left and right. So what I would do is I would pick a point on the line, like where I am right here, and I'm going to go up from there. So this part up here is above, which almost looks more like left. But it actually is above it. So this area here would be our solution. So this area over here. Probably should have done dashes, but this is the solution right there. Determine if it's a point in the solution set. So 1, 2. So let's find 1, 2. 1, 2 is right here. 1, 2 is on the boundary of a dashed line, which makes it not in the solution set. So this would be no, because 1, 2 is on a dashed line, which is not included, not in the solution set. Okay, 36. Here we go. 2 more to go. This one wants a linear regression for this data. So we're going to go to a spreadsheet. We're going to type this data in. It says math and English, so we're going to do math. And we're going to do ELA for our columns. Or whatever, doesn't matter. So 27, just going to put all the data in. Oops. 12, 13, 10, 30, 45, 20. 46, 28, 45. The key is just not to miss any. Okay, before you can do the linear regression, you can't stop here. See how I got that box still highlighted? Gotta hit enter on the last one. Very common mistake is to mess that up and not hit enter first. We go back up here, go to statistics, stat calculations, linear regression. I did choice 4. I'm going to pick, it says math is X and ELA is Y. And there we have it. So I'm going to do Y equals A plus BX. So it wants nearest hundredth. So 22.948 would be 22.95. I'm sorry, it's 23. Where did I get 22 from? Sorry about that. Let's try again. 23.95 plus the slope, which is a positive 0.957, so 96x. Equations always have equal signs. Don't forget the y equals part. You lose a whole point for that. What's the correlation coefficient as expected? So that's always r. So correlation coefficient is r, not r squared, to the nearest hundredth. So 0.92. And what does it mean in context? We have to say there's a strong or weak. So this is strong because it's close to 1. So close to 1 or negative 1 means strong. So there is a strong and positive, because it's a positive number, correlation between what we're talking about. So between, just add the context in. So between percent of students scoring 85 or better on math and English. So a little bit of writing, but we can handle it. So strong positive correlation between students who scored greater than or equal to 85 on math and English exams. There's the context part. If you don't say the context, you lose some credit too. So make sure you say not only what the correlation means in terms of strength and positive or negative, but also in terms of what we're talking about, the actual context. All right, question 37, last one. What is this talking about? Talking about coins and sorting and 90 coins and the value. Nice little system. They love making systems for part 4s because it's a great way to get 6 points. And these should be great. If you see one of these show up on a Regents, you should be happy to see it as a part 4. Usually they're not too bad. So we're talking about dimes and quarters, 2 variables, or 1 variable. You actually can do either way. That's kind of interesting. So either way you do it, they're allowing you to do it. So I'm going to do a system. So we're talking about dimes and quarters. So I'm going to use D and Q. So the dimes plus the quarters equals our total coins, which is 90. And the money here, so 10 cents per dime plus 25 cents per quarter equal to 17.55. That's a system. Now using our system, algebraically solve it. So I'm going to use a scale factor here of times. You know what? I'm actually not going to do that. I'm going to do it a different way. I want to get rid of decimals. I'm going to do the bottom one times -4. You'll see why in a second. So I'm going to keep the top the same. D plus Q equals 90. The bottom one times -4, so -0.4D. And then -4 times 0.25 is a -1Q equals, and then go back to my calculator, 1755 times, let's see, -4 I said. So that's -70.2. And then now if I add these, I can get rid of the Q's. So it'd be positive 0.6D equals, looks like that would be 19.2. Let's just check that. 90 minus 70. Oh, not 0.2. I meant 0.8. Yep, there it is. I knew that. Good thing I checked it. All right, then divide by 0.6. And you get D equals something. The problem is the question actually wants the number of quarters. So as good as that was to find 33, that is not the answer we wanted. If we did it a different way, we could have gotten Q. I probably should have read that first. I didn't. So let's find Q anyways. So D plus Q is 90. So 33 plus Q is 90. So let's just do some simple subtraction. Not the end of the world. We can subtract, I hope, 90 minus 33, 57. So there's our answer, 57 quarters. It doesn't actually want both. It actually just wants the number of quarters for some reason. The last part here, Dylan's mom says that all the coins are going to be quarters. Each of his dimes are now a quarter. So he uses all his coins, so there are now 90 quarters. Will that be enough money to buy a game for that much money with that much tax? So $20.98. I'm going to do that times 1.08 to figure out how much it is after an 8% tax is added on. I can do it all at once because 100% is the original plus 8% added on is the 108% total that we're looking for. So that's the 1.08. So that times 1.08 is equal to 22.6584. nearest cent, of course, for money, so 22.66. So is 90 quarters enough? Well, let's do 90 times the value of each quarter and see, is that enough money? Oops, too many buttons here. That's $22.50. So this is what he has. This is what he wants. Does he have enough? No. So no, Dylan does not have enough. And if you read the question there, it says to justify. So justify means to show work, and this is plenty of work. So he only has this much. He needs this, so he needs this, only has that. That's a clear justification of not having enough. And that's the short answer for this whole test.